Hello class. Today we'll be learning about triangle congruency. First, context knowledge. During this lesson, students will be able to understand how SAS can be used to show triangles are congruent. Also, I'll be demonstrating how to prove SAS and how to use SAS to solve other problems. For the pedagogy goal. As a teacher and for many students, this program can be very useful because it helps us visualize triangles, formulas, and graph for better understanding. We're not only memorizing formulas or theorems, we're actually understanding the material and saving it in our long-term memories. Now, some students might have some questions such as, does the third side have any effect? Can we use other postulates to prove SAS? When is convenient to use SAS? And if we are given a side and an angle, can we still solve the problem using SAS? And for the technology goal, using Sketchpad, I will have the triangles made for proving congruency. I would also have measurements, and I will also use color to differentiate between the sides. This would also help us visualize and understand the pictures better. Now, I have a mini introduction right here. Side angle side states that if two sides and the included angle of one triangle are congruent to the two sides and the included angle of another triangle, then the triangles must be congruent. Now, I have a mini example right here which says that triangle ABC, which is this one, and triangle DEF, which is this one, are congruent because sides AB and DE are congruent. As we could see right here, they have the same color to help us visualize and recognize that they're congruent. We have also side AC, which is this one right here, AC and DF, which are congruent too. And then we have angle BAC congruent to EDF. Therefore, by the postulate SAS, the two triangles are congruent. Now we're going to do a better proof. Side angle side. So our goal to show that these two triangles are congruent, we have to somehow align the measurement angle CAB and the angle FDE on top of each other. We have to align them so they could lie on top of each other. The same is going to happen with AC and with DF and AB and DE. So the way we're going to do this is that we're going to construct segment AD, and then we're going to find the midpoint of AD, which is point H, as we can see right there. We're also going to construct a perpendicular to AD. This perpendicular line, we're going to use it to reflect this triangle over the perpendicular, so we could have this point D to lie on top of point A. Okay, so we're going to reflect, but then what I'm going to do is I'm going to hide my perpendicular bisector and my line segment the same as well as my other triangle. I'm doing this because I don't want to have all these kinds of images in my screen, and it's going to make it more difficult to understand. So now that I have hide those images, now I have to construct an angle bisector of angle B, A, and E prime. So I'm going to go ahead and do that. Now that I did that, I'm going to reflect this triangle right here over the angle bisector. Now I'm going to go ahead and do that, but I'm also going to hide my triangle and my angle bisector. So now, as you could see, I have my two triangles laying on top of each other, meaning that these two triangles are congruent. Now we're going to go ahead and do an example. Example number 1. In the diagram below, point D and point E are points on segments AB and AC respectively. Now we're giving that AD and AE are congruent, the same as DB and EC, which are also congruent. So now we have to prove that the side DF and EF are congruent using SAS. So we could see we have our line AB, which is all this line, which is congruent to this whole line. They have the same measurement, the same as AD and AE. They're congruent. They have the same measurement, and the same with DB and EC. So now, in order for us to solve this problem, we have to somehow find two triangles inside of this big triangle so we could show that they're congruent. We somehow have to find two triangles inside of this triangle to show that they both share these two sides, and that will make them congruent. So the way we're going to do this is that we're going to construct an angle bisector of angle DAE. There we go. Now, by creating the angle bisector, we have at the same time created two separate triangles, which we'll be using to prove our congruency. So now, as you can see, I have my two triangles right here. Now, we have extra information that we don't want, so we need to somehow erase it or hide it so we're not confused, we don't get confused, okay? So what I'm going to do is I'm going to hide the two triangles that I created, but I'm going to show the two triangles that I'm going to work with, okay? I have triangle AFD and AFE, right? Now, we know that the line AD is congruent to line AE, which is given over here. They give it to us. Now, we also know that the line AF is congruent to itself. And as we stated before, we know that our angle DAF is congruent to our angle EAF by the definition of angle bisector. Now, by SAS, we know that our triangle AFD is congruent to our triangle AFE. Therefore, if these two triangles are congruent, this side is congruent to this side is congruent to itself, and these two angles are congruent to each other, then it has to be that this line is congruent to this line. And there we go. We have proven using SAS that line DF is congruent to line EF. Thank you.